Hello and a warm welcome. I am Armin Trost, Professor for Organizational Behavior at the Furtwangen University in Germany, and this is my course on social research methods. So hello everybody. With this episode we start a little series about multivariate statistics. And under the umbrella of multivariate statistics there are a couple of different types of statistical analysis. One is, for instance, factor analysis. We're going to talk about this today in this episode. Then we have things like multiple regression analysis or multidimensional scaling, cluster analysis, discriminant analysis, structural quotient modeling. So there are all sorts of different multivariate statistics. And what's common among those statistical methods is that you have multiple variables. Not only two, one independent and one dependent variable, but you have many variables. 3, 4, 5, 20, 100, 200. And what you want to do with multivariate analysis is you want to find structures, you want to find a common logic, you want to find an underlying order in which is otherwise very diverse or diffuse. And today we're going to talk about factor analysis, and maybe I can start with some fundamental ideas out of social science. Well, for instance, when you look at leadership research about leadership, what we always did since decades is that we were looking at leadership behavior, for instance. And when you look at leadership behavior, you find that different leaders show a huge variety of different behavioral patterns. To put it simple, some leaders listen, some motivate, some decide, some trust, some are focused on on decision making, on problem solving, some are caring, so this can go on and on and on. I mean, how many different behavioral patterns are there related to leaders? I mean, there are thousands, right? And what we want to do, for instance, in the area of organizational behavior is we want to understand, is there an underlying structure, underlying metrics, some underlying coordinates like south and north and west and east, yeah? And with regards to leadership research, for instance, we found out that you can describe any kind of leadership behavior along two dimensions. Two underlying dimensions. We name these factors. And one dimension is, to what extent are leaders focused or interested in the things, the task, the problem? And the other factor is, to which extent are leaders focused on people and interpersonal relation? So there can be leaders who act on both factors on a very high level. You are very much interested in tasks, but also you're very much interested in people, the social thing. And some are maybe high on one thing but low on the other. So what you see here is there is an underlying structure. And this is what we want to do with factor analysis. And maybe I can add another example from social research or from social science. And that's, in my eyes, the perfect example for how we can use factor analysis. That relates to differential psychology. Differential psychology is about how people differ, individuals. to put it more specific. How do individuals differ with regards to their disposition? And people can behave in all sorts of ways. Some are more interested in this, some are more interested in that, some are more show more this behavior, some show more that behavior, and you know it, and you can experience from your daily observation that people differ, and also you yourself differ from other people. And a fundamental question in psychology was always, can we describe the difference of personality? The difference of personality based on a few underlying factors, right? And how many are there? And what are these factors? And historically, one of the most famous approaches came from Raymond Cattell. I mean, he was one of the, I would say, one of the fathers of personality psychology, when we could say this, differential psychology, because what he did, it's a wonderful example for factor analysis. What he did, he and his colleagues, he looked at 4,500 adjectives that are somehow used in the English language. Okay, when you look at 4,500 adjectives that all could somehow describe people, when you look at these 4,500 adjectives, you will find that there is a lot of redundancy within, right? And based on the semantic meaning of those adjectives, they boiled it down to first 180 and then to just a few, around 40, 50 adjectives. Okay. The idea behind is what we name the lexical hypothesis, is that the human language, the language that we use, does reflect human nature. That might sound silly to you. It's not so important now with social research, but that's the underlying hypothesis, that we assume that with a human language, the language that we use, we are able to fully describe the human nature. Okay? So, I mean, what are these kind of adjectives? Adjectives like loud, happy, social, caring, all these kinds of things. Okay, so then Raymond Cattell asked many people. I could tell you how many. I could not tell you how many people. I mean, there were several studies around, but there's many people to describe themselves or others based on those adjectives. Does that adjective apply to you or not, or to what extent? Okay, so when you do this, and when you describe many people based on many adjectives, right? I mean, you can imagine, then you have a very big raw data matrix. You might have in the column all the adjectives, and in the line you have all those people. And what you could do now is you could look at how these adjectives interrelate. And what you find is that sometimes, very often, if people are described with one adjective, probability is very high that they are also described with another adjective. Maybe it's, just to pull an example from the air, maybe it is that when people say they are happy, very often they also say that they are lucky. Right? Or maybe when people say they are very calm, could be that they also say that they are very modest, silent. Yeah. It could be that if somebody says, I'm very much outgoing, that those people who say they are very much outgoing, that they also tend to say that they are very social. Okay, so and when this is the case, you now can calculate an intercorrelation matrix. Yeah, And now when you have this intercorrelation matrix, what they did, Raymond Cattell, is they boiled it down to a very few factors which are common. You could, so to speak, cluster some adjectives. Those five adjectives, they relate so much to each other that they can be reflected by a single factor. So we summarize a lot of adjectives into one factor. That was the idea with Raymond Cattell. And Raymond Cattell came up with 16 different factors, and that's why it's called the 16 personality factor model. Things like abstractedness, apprehension, dominance, emotional stability, liveliness, openness to change, and all these kind of things. And that was one of the first attempts into that direction, using the factor analysis. The interesting thing is that at that time, when Raymond Cattell did this analysis, they did not have computers, at least not those kind of computers that we use today. So they made this analysis in the semester break, and they rented the sports arena, the sports hall, however you name it, and made a huge intercorrelation matrix on the floor of this hall. Yeah, and then they start to sorting things. It's amazing. It's amazing. Yeah, but to show you the underlying idea of factor analysis, here you find a very, very simplified intercorrelation matrix. It's very simplified. Let's assume we have 8 items. An item, I mean, that could be an adjective, right? Or a kind of question about a human behavior or a human characteristic. Okay? 8 items, 1 to 8. And what we can do with those, once we have the data for all these 8 items, what we can do is, as I already said, we can calculate an intercorrelation matrix. And this intercorrelation matrix has the same lines as the columns. Okay? There is a diagonal, when you can say this that way, symmetry. Okay, as you can tell from this picture. So for instance, here you see different cells. Some cells are white or empty. That means there is no correlation. Gray means there is a correlation, a high correlation. Let's put it that simple. It's a little bit black and white, but that helps for the moment. Some items do not correlate, and some items correlate. So for instance, here in this example, item 1 correlates high with item 6, but not with item 7, but correlates high with item 8. Okay? So this is what this little, very, very simplified intercorrelation matrix indicates. And I wanted to simplify it here for the matter of learning. So what I did now is I took exactly this intercorrelation matrix and I sorted it differently. And now I get this. Now I get the same intercorrelation matrix. But what you see now is there seem to be some items, namely item 1, 6, and 8, where it's a high intercorrelation among these 3 items. But these 3 items, 1, 6, 8, do not correlate with all the other items. When you look at the other items, for instance, 3, 5, 7, 2, you realize that these also very highly intercorrelate, but do not correlate with all the others. So it seems that there are 2 factors. Isn't that cool? I find this cool. Yeah. Okay, there's item 4. That does not correlate with anything. Pull it out. But you see, the fascinating idea of factor analysis, that you start with a completely unstructured, diverse set of data and variables, and you put everything into it. Then you collect the data, and then you run a factor analysis, and at the end you get 2 factors. And the whole world, everything that you have measured, now gets sorted into something which is far, far, far more simple than what you had in the beginning. Okay, so let me share with you some fundamental thoughts around factor analysis. Yeah, factor analysis, as I thought, is a multivariate statistical procedure, and as you have seen now with everything I've said, it's there to reduce complexity. It's amazing. It reduces complexity by bundling or clustering various items into single independent factors, as you just have seen. And now let me share with you two important terms or two important concepts which are related to factor analysis. At least these two are those that you really should understand. Okay, I mean, it's when you run a factor analysis, which is pretty simple with the statistical tools that we have today. You're gonna get some outputs, and one output is that you get so-called factor loading. Factor loading is always represented in a table where you have the items, your original items, in the lines, and you have the extracted factors in the column. And in the cells you will find so-called factor loading. So here is an example. You see here that item 1 to 4, in this example they have a very high factor loading on factor 1, but item 5 or 6, they have low factor loading on factor 1, but they have a high factor loading on factor 2. So this is what you get. This is a very simplified result, but you can imagine this also as a very, very, very big table where you have not just 6 items, but you have 100 items maybe, and you have 6 factors or 4 factors. So what you do then is you look at all the items that load high on, let's say, factor 1. You look at these items, and what you do then, and that's the creative part of factor analysis, that's the creative part. You really look at the content of those items and you try to see any kind of meaningful things in these items. You try to find the common idea behind these items. What is common among all these things? What do all these items in total, what do they represent really? And this is something that your analysis does not tell you. This is pure interpretation, nothing else. You really have to interpret now. This item is high on this factor, this item, now look what is this? Okay, one item is I like to party, the other item is I like to meet people, and the other item that loads high on this factor is I like to have as many friends as possible, I like to dance, and you say party, dance, many friends. That sounds a little bit like, today we would name it extraversion, right? Maybe we can put it that way. So it's also interpret. Okay, so factor loading tells you to what extent a single item correlates with the extracted factor. Okay, that's it. Now, what you want is that with a factor, in a factor analysis, that the factor really explains the variance of as many items as possible, because you want to reduce complexity. You want to translate many items into a few factors. So here is another concept which is key for factor analysis, which is the eigenvalue. The eigenvalue. The eigenvalue tells you the extent to which a factor explains variance in the total data set. And the eigenvalue tells you how how much variance of how many items does that factor explain. So in our example here, factor 1 has an eigenvalue of 3.9. That means that this factor is capable of explaining the variance of 3.9 items. That summarizes 3.9 items into one factor. So having that said, it also makes absolute sense that we do not extract factors that have an eigenvalue lower than 1. Because what we want to do is we want to reduce complexity and we don't want to increase complexity. So here's the third concept around factor analysis. What we typically do is the scree test. What you always find that in the beginning of the factor analysis, there is one factor which has a high eigenvalue. That explains a lot of variance. Then the second factor that is extracted has a lower eigenvalue. That's always the case. Don't ask me why. And then the third factor has even less eigenvalue, and then you have the remaining rest, and the factor analysis analyzes as many factors as needed so that the total variance of the entire data set is explained. But you don't want to explain 100% of variance, you want to explain a significant amount of variance. So you stop somewhere. So you have this diagram, we name it the scree test, and you cut at the point where the line becomes horizontal. So sometimes it's one factor, like with intelligence, for instance. Intelligence, one factor, yeah, or 2 factor, 3 factor, and you look at the scree test and say, okay, where is the cut where things become very low with regards to eigenvalue? Okay, so that's factor analysis, and I started with differential psychology, and I would like to finish this episode with differential psychology. And of course, in personality research, we did that. We did exactly that. And the fascinating thing is that there is a common view in the social scientific community that when we analyze personality, that we will end up with 5 factors, the big 5-factor model. I don't want to go too deep into that, but I just wanted to show you this, because that's exactly a result of factor analysis. And what are these 5 factors? Openness to experience. To what extent are you creative? How much are you engaged in intellectual things? How curious are you? Yeah, how open are you to change? And so, yeah, the other one is conscientiousness. People who are high on conscientiousness, they love order, they love rituals, they love to plan things, and then they stick to it. People who are high in conscientiousness are very, very reliable people. Yeah, extraversion. These are those who love to go out, love to meet people, love to have party and all those things. These are the visible people. Sometimes are the loud people. Yeah. Very spontaneous very often. And then there are the agreeableness, there's agreeableness at the 4th factor. If you load high on agreeableness, you put the interest of others over the interest of yourself. That's agreeableness. And the 5th one is neuroticism. It's whether you see the risk in things, where you are careful and where you sometimes are anxious also about things. You do not take risk. You always see the threat in something, which is not good or bad. I mean, it's good to see threats in things, right? Otherwise you would walk through life like a moron and you would not survive at all. So these are the 5 factors of personality. It's interesting. It's not 1 factor. It's not 12 factors, it's not 50 factors, it's 5. And it's very well accepted. And as I said, this is a result of factor analysis. Okay? So I would like to leave it to that. And next time we're going to have a little look on multiple regression analysis. So thanks for having you here today. And we see us in the next episode.